Alright, good afternoon or good day, class. Okay, so right now, I will discuss to you about work, energy, and power. Okay, so we have here a work done by a force. When a constant force acts on a particle that undergoes a straight line displacement, S, the work done by the force on the particle is defined to be the scalar product of F and S. So the very simple definition, class, of work is that it is the product of the force and the displacement. Again, the dot product of the force and displacement. So when we say dot product, class, that is a scalar product. So please do not write work as F times S like this one, because this one is a cross product. So a cross product is a vector product. So you have to write it this way. F dot S, meaning it is the dot product of the force and the displacement, this one. The unit of work in SI units is 1 joule. So if you have your force in Newton and your displacement in meters, so you have the unit Newton meter, or 1 Newton meter is what you call the unit joule. 1 joule, it is named in honor of the 19th century English physicist James Prescott Joule. Kana siya nga unit joule. Again, that is Newton meter. Work is a scalar quantity. It can be positive or negative, but it has no direction in space. So again, since it is a dot product, meaning to say that work is a scalar product, or your product there is a scalar quantity. Now what we have here is Fs, or when we say Fs cosine phi, now what we want is the force, but if, say for example, our force is directed at an angle, because what we're going to get is the component of the force that is parallel to the direction of your displacement. Say for example, this is your x and then this is your y. And then your movement, like for example, you have an object, your movement is along x, so it could be to the right or to the left. So your displacement is along x. So it should be that your F here is directed along the direction of the displacement, or not along, it could be left or right, but it should be parallel to the direction of the displacement as well. So that if your F is directed at an angle, you will simply have to get the component of F that is parallel to the direction of your displacement. So that, like for example, this one, as you can see, your F is directed at an angle phi. So in order to get our work there, you must get the dot product of F. As you can see, you have here the bar that is the component of F that is parallel to the displacement, and then multiplied by the displacement. So when we consider this illustration, you have here your F inclined at an angle phi. So we will, our displacement along this line here. So we will get the component of F along ani. So that is F cosine phi, no? Our component of F that is parallel to the displacement is F cosine phi. So that is why that is F cosine phi then times the displacement S, or that is Fs cosine theta, this one. The component of F that is parallel to the displacement then times the displacement itself. Now for English unit, for SI, that is joules. For English unit, our used unit is foot-pound force. Foot-pound force. Your unit of force is pound force, and then your displacement unit is in foot or in feet. So that is That is foot-pound force. Actually, mo siyang balihon na lang. Foot-pound force. Then, while for CGS, you have your unit of force in dynes, and then your unit of displacement is in centimeters. You have dyne centimeter, or dyne centimeter is what you call the unit ergs. This dyne centimeter. Next, we have work, positive, negative, or zero. So when do we say that work is positive, work is negative, and when do we say that the work is zero? So a constant force F can do positive, negative, or zero work depending on the angle between F and the displacement S. So it depends on the angle. The force, for A, as illustration A, as you can see, our displacement is along here, along this one, and our force is going at an angle phi, this one. So as you can see, it has a component, this one. Ayahang component that is parallel to the displacement is same in the same direction, no? In the same direction, which is, as you can see, to the right, parehas lang to the right. So in this case, our work here is positive. The work done on the object by force F is positive since the component of the force is in the same direction as the direction of our displacement. No? As you can see, pareho sila to the right. This one and the direction. Letter B. Now we are still given, force is given at an angle phi, but as you can see, if we try to look at, we have this component of F along X. So kanin siya, this component right here. And then our displacement is along this one. So as you can see, it is to the right, ang displacement, S. Then ang component of F that is parallel to displacement is this one. Opposite direction sila. If our displacement is to the right, ang parallel component is going to the left. That is why, in this case, our work done on the object by this force is negative. Mathematically, work is less than 0 or negative atong work na ma-obtain because F cosine phi is negative for when your angle is greater than 90 degrees but less than 270 degrees. That is, you can obtain a negative answer for that. So, ang imong work is also negative. Letter C. So, ani nga time tama kaingon that your work is 0. So, when is that? If your force is acting perpendicular to the displacement. So, if this is our displacement along X, going to the right, if you have your force that is perpendicular, so 90 degrees is siya class, with the displacement, direction of the displacement. 0, since 0 atong work, since your phi right there, if it is perpendicular, so 90 degrees. So if you try to calculate cosine 90 degrees, that is 0. So meaning to say that that force is not acting any work on that particular object, no? So if force acting on an object has a component perpendicular to the object's displacement, that component does no work on the object. The force does no work on the object. So 0 ay mohang work for that. Okay, let us have sample problem number 1. A tow truck pulls a car 5 kilometers along a horizontal roadway using a cable having a tension of 850 newtons. Letter A. How much work does the cable do on the car if it pulls horizontally, or if it pulls at 35 degrees above the horizontal? And B. How much work does the cable do on the tow truck in both cases of part A? Letter C. How much work does gravity do on the car in part A? So we have to answer this one, we must draw first the problem. Okay, so we have a car and a tow truck. Suppose we have a car here. Di man siya straight. Sama ta. Again. Okay, we have a car. And then we have a tow truck here. Suppose this is our tow truck and the car. Now, we have a cable. The tow truck pulls a car 5 kilometers along a horizontal roadway. So we have S to be 5 kilometers. 5 kilometers. So we have a cable. What if the car is being pulled horizontally? So letter A, ito sa butang ta A.1. If the car is being pulled horizontally. This one. So if it is pulled, natay cable nga nag-pull sa car, so meaning to say natay tension, class. Tension. So it is directed away from the object. Bitad. So for letter A, how much work does the cable do on the car if it is pulled horizontally? So ang tension is 850 newtons. So from the formula of work, we have Fs cosine phi. So our force is kaning bitad nga tension, no? Which is 850 newtons. Your displacement is 5 kilometers. So we have to convert this to a meter. So that is 5,000 meters. Then cosine of phi, your angle here, since our displacement is along man gid pud siya dire, no? Since gibitad man siya pa right, so paadto ato ang displacement. So our parallel siya, so our phi is there is 0. So cosine 0 is 1. So that is simply 850 times 5,000. Your answer in Newton meters or in joules. So that is 4.25 times 10 to the power 6 joules. Okay. Ari pa ta sa letter A. But let's say that is A.2. If it pulls at 35 degrees above the horizontal, so same, how much work is done to the car if it is being pulled at an angle? So mao ni ang bitad niya. So at an angle 35, this one is 35 degrees. So still work is equal to Fs cosine phi, and our phi right now is 35 degrees. So still the same tension and displacement 5,000 meters, then cosine the angle phi 35 degrees. So work 3.48 times 10 to the power 6 joules. So of course, if you pull the car horizontally, straight horizontally, much work is done on the car. It's more effective. B, how much work does the cable do on the tow truck in both cases in part A? So in this case, we will focus our free body diagram on the truck. So on the truck, we have, say for example, this one. Say for example, we have this truck. our displacement, di ba, is aning gihapon along x, ato ang displacement, and our force for B1, if it is applied horizontally. So, kay cable man siya class, straight horizontally, so bitad gyapon na siya class ang tension. Away gid gyapon siya, no? Away from the track, which is 850 newtons. So, away. As you can see, di ba, nagbitad man ta sa track, no? So, atong displacement is along x, padung adto. Ito ang displacement. And then, our force or the tension is going pa-right. So, when we try to calculate work, Fs cosine phi, our phi now, so from here, our angle is this one. Ilan naman ito angle again? That is, kana siyang angle. So, our angle for that is 180, or angle phi na to is 180 degrees. So, we have 850 times, that is Newton, times 5,000 meters cosine 180 degrees. So, negative class. Negative 4.25 times 10 to the power 6 joules. Negative because opposite na sila og direction. The track, this is the track. Dire, ang ato ang focus is the free body diagram of the car. For B.2, if it is directed at an angle 35 degrees, so kani siya man, di ba? Kani. So, bitad na siya. So, kung kini siya class 35, therefore, kini pod siya, kini siya nga angle is also 35. So, kung if this is 35, again, this is also 35 degree angle. So, therefore, pila na itong total angle from here? This is 180 plus 35. Una natay angle nga phi nga 215. So, still the same formula, Fs cosine phi. And then your phi now is again 215. So, this again in 215. Again, this is, since this is at an angle 35, this one is also 35. And then from the horizontal to that, it is 180 plus na below pa yung 35. So, 180 plus 35. That is why you get an angle 215. So, your work now is negative 3.48 times 10 to the power 6 joules. And then lastly, for letter C, how much work does gravity do on the car in part A? So, gravity, when say gravity, so nag-refer na siya sa effect sa weight, this one. So, since the weight is directed vertically downward, then our displacement is along x. Therefore, it is perpendicular. So, work done due to gravity is 0. Or, you have, if you try to solve that one, your phi there is 90 degrees. So, cosine phi, cosine 90 degrees is 0. So, your work is 0. Now, let us have total work. The total work done on the body by all the forces is the algebraic sum of the quantities of work done by the individual forces. So, again, is the algebraic sum of all the work done by the individual forces. So, total work kintahay na kay 3 forces acting on a body, so you should get the algebraic sum of all the works. So work due to force 1, algebraic sum meaning to say you must include the sign, no? Consider the sign convention, plus total work 2 plus force 2 work, and then plus the work done by the force 3. So, na the quantities, the algebraic sum of the quantities of work done by the forces. An alternative way to find the total work is to compute the vector sum of the forces. So you will get the net force, or again the algebraic sum of the all the forces, and then use this vector sum as the F in the first equation, in the equation that we have for force, for the work. So ang ato ko nung F here nga gamiton kani siya class would be the summation of all the forces acting on the body, so that the total work now is the summation of the force then times the displacement S. For example, okay, let us try to find the total work in this example. The farmer hitches her tractor to a sled loaded with firewood and pulls it a distance of 20 meters along the level ground. The total weight of sled and load is 14,700 newtons. The tractor exerts a constant 5,000 newton force at an angle 36.9 degrees above the horizontal. There is a 3,500 newton friction force opposing the sled's motion. Find the work done by each force acting on the sled and the total work done by all the forces. So, daghan siya nga force na nag-act sa tuang sled. So, let us try to have this one. Okay, let us draw the free body diagram, or let us draw all the forces applied in our sled. So, our sled is this one. So, gibitad na siya sa tractor, no? So, of course, our displacement is along adong tata right. Now, what are the forces acting on this sled? First, naa siya weight, total weight so firewood na ni siya in the sled, that is 14,700 newtons. So, we have the weight, downward force of the weight. $14,000. Next, we have ang bitad ko na sa tractor, which is at an angle phi, at an angle 36.9. So, kung kanin siya, gibitad na siya na. So, ang batang kanin siya. Ito lang siya ibalhin, ha. Kay the high tension, basta bitad class, that is tension, which is 5,000 constant at an angle 36.9 degrees. Next, we have the friction force. So, sa akong gimension ninyo about friction force before. So, if the direction sa motion nato is going to the right, ang friction force is opposing the direction of motion, since it is a retarding force. So, this is our friction force. 3,500 newtons. So, other than that, nasa tayo normal, diba? Natay normal force that is perpendicular to the surface. This is so, you have 4 forces acting on this. So, work total now is equal to the algebraic sum of the total work done on our sled, which is natay work done by the weight, natay work done by the normal force, plus the work done by the tractor, tension niya from the tractor, and the work done by the friction force. So, we must get the individual work first, then get the sum. So, for the weight, since it is perpendicular, so 0 si weight. As also, the normal work due to the normal force, since it is perpendicular to the surface, so pareho na sila nga 0. Okay. Next, we have to get the work due to the pull sa tractor, which is given by the formula Fs cosine phi, and our phi here is given at an angle 36.9 degrees. So our force constant tension is 5,000 newtons. Our S, by the way, pila tong S ani? 20 meters. Cosine phi 36.9 degrees. So work due to the tractor is 79968. 79968.47 joules. 0.47 joules. Or in kilojoules, that is, ito na lang siya mag-round off na 80 kilojoules. Okay, 80 kilojoules. That is the work done by the tractor. Next we have is the work done by the friction force, Fs cosine phi. Now what is our phi right here? So pa-right ang ato ang direction sa tractor, our friction force is opposite niya. So iyahaan ng phi is 180 degrees. So friction force is 3,500 newtons. Then 20 meters cosine 180 degrees. So that the work done by the friction force, my expected negative answer, this is 70,000 negative 70,000 joules, or in kilojoules, this negative 70 kilojoules. So nakuha na nato tanan, no, na natay 0, this is 0, this nakuha na nato, and this one also. So substituting from the formula, the total work now is equal to your work due to the weight 0 plus work due to normal force 0 plus you have work due to the tractor 80 kilojoules, and the work done by the friction force negative 70 kilojoules. So the total work now is equal to 80 minus 70, so 10 kilojoules. That is now your final answer. Or let us try to solve this problem using the alternative solution. The total work is equal to the summation of forces then times the displacement S. Okay, so summation of forces considering upward forces, I know, upward, that is considering forces to the right as positive. Considering forces to the right as positive. So, we have the weight and the normal force. They don't have x components. They don't have a component that is parallel to the displacement. So, ang naa lang is the tension, which is T cosine 36.9 positive. Going to the right man siya, kani siya. So, that is T cosine 36.9. And then, F. So, si F is, klaro kayo, no? Pa-left. So, minus F. Okay. So, si summation of F pa ni siya. So, summation of F, that is 5,000 cosine 36.9 minus 3,500. So, your summation of F, therefore, you have 4 498.42 newtons. Or, if we round off, kaya nag-round off man ta diri, so we will round this off. That is 500 Newton. 500 Newton. So that, to get the work total, using this alternative solution, we have summation of F times S. So that is, summation of F nato is this. 500 Newtons times the displacement 20 meters. So that is 10,000 Newton meter, 10,000 joules, or that is 10 kilojoules. So we have obtained the same answer using the two different solutions for the total work. So the other one is we get the individual work done by the forces and then get the algebraic sum. And then the second one is to get the summation of forces and then multiply that one by the displacement S. Okay.